Lesson 10, last lesson in the chapter. So let's get this going. We're talking about parts of real numbers. So we're talking about subsets of real numbers. So as far as you're concerned, real numbers are every number that you can think of. There are such things as imaginary numbers, but no, I'm not just making that up. There are imaginary numbers, which you will learn about later in high school. But for right now, everything you know is a real number. So whenever you talk about real numbers, this chart on this page, rather important for you to know. Okay, I want these copied down in your notebook. So real numbers basically has two divisions. Division of rational numbers and irrational numbers. So just for you to have in your notes, let's get a little bit more writing room here. I guess I need to erase my line now that it's gone, or at least in the wrong spot. So let's talk about rational numbers. So rational numbers, anything that can be written as a fraction. So rational. Anything I promise I have much better handwriting than this. Anything that can be come on, be written as a fraction. So the opposite of that would be, of course, irrational numbers over here on the other side. So if rationals are anything that can be written as a fraction, you could probably guess what irrational numbers are. Numbers that cannot be written as a fraction. Numbers that can't be written as fractions. All right. So, rational, you're either rational or irrational. Rational, irrational. Within irrationals, you just have numbers that will never come out even, such as pi. As you know from the big poster in the room, pi never comes out even, never repeats. This number right here, 2, 1, 2, 3, 1, 2, 3, 4. There's no pattern, it does not terminate. Square root of 3, we've learned that square root of 3 does not come out even. That was our lesson last time about perfect squares. 3 is not a perfect square. So it's going to be somewhere in between 1 and 2, but it will not come out even. So irrational, basically just that. Basically anything that rationals are not. So within rationals, you have your fractions and decimals. All those are rationals. But you also have another subset called integers. Integers. And how I want you to think of integers as anything you would traditionally see on a number line. Anything you would normally see on a number line. See? Oh, this thing is such a pain. On a number line. Anything you would traditionally see on a number line. So that's all your positives, negatives, and 0. After that, you've got your whole numbers. Whole numbers. Whole numbers are 0, 1, 2, 3, 4, and on and on and on. Those are all the whole numbers. Now, natural numbers. Natural numbers are also known as, or also thought of as, counting numbers. So these are just the ones that you use to count everyday things. Counting numbers. Okay? So these, what numbers do you usually use to count? You're not going to start counting with 0. You're going to start with 1, 2, 3, dot, dot, dot. Okay? That dot, 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 that's an ellipse. An ellipsis. An ellipsis tells you that it keeps going and going and going. So if we talk about rationals, irrationals, integers, wholes, natural, or counting, I will take either one of those. Really doesn't matter to me. You need to be able to distinguish between them. They are all vocab words for you to use, so distinguish between them and be able to identify to which sets of numbers these numbers belong. So let's move down here. Examples. Number 1, name all sets of numbers to which each real number belongs. So obviously you can see if this is 2525252525, that is a repeating decimal. So if it's a repeating decimal, that puts it in rational. And it is rational only. It is not, obviously if something's rational, it can't be irrational. It's one or the other. It's not, you don't normally see this on a number line. These are not a whole number, nor is it a counting number. So it is, oops, dropped my pen. It is rational only. All right, square root of 36. Square root of 36 we know comes out even as 6. So you have to decide between, is it rational, irrational? Since it can be written as a fraction, 6 over 1, so it is rational. It is on a number line, so it is an integer. It is a whole number, and it is a number that we traditionally use to count with, so it is a natural number. All right, square root of 7. Square root of 7 does not come out even, nor does it ever repeat. That is the reason why it is an irrational number. So if something is an irrational number, it takes it out of contention for anything else. Because if it is irrational all by itself. If it's irrational all by itself. So this one kind of has its own class going on for it. Irrational is all by itself. All right, so pause it and try A, B, and C. All right, now that you're back with me, square root of 10. Square root of 10. 10 is not a perfect square, so that means this is not going to come out even. So this is irrational. Negative 2 2/5. Well, obviously that is a fraction, which means it is rational. So once it's irrational, we can start going down the list here. It is not a number normally seen on the number line. It is not a whole number. It is not a counting number, so it's rational only. Square root of 100. Square root of 100 is 10. So 10 can be written as a fraction, so it is rational. Now, once it is rational, we can start going down all the other ones. So, is it a number we traditionally see on the number line? Yes. So it is an integer. Is it a whole number? Yes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is a whole number. Sorry, 0, 1, 2, 3, 4. It is a whole number. And if it is a whole number, then it's definitely a counting number. We can count things to 10. So counting or natural, either way you want to put it, is acceptable. Counting or natural. Okay. Let's try a little more. I'm going to try and just erase it this time and leave my little charts over here. Okay. So leaving those definitions up there on the board. We're talking about comparing and ordering real numbers. Comparing and ordering. Really? I went back to the whole last lesson. Telling you, Friday the 13th. That's what does it. There we go. Comparing and ordering real numbers. You can compare and order real numbers by writing them in the same notation. So you can compare them if they're written in the same form. It is hard to compare square root of 7 and 2 2/3. Okay? It is hard to do that. So let me get, just for a second, let me get these definitions off so that way you can see, and then I will bring them back up here. And that didn't quite work, did it? All right, let's do this. Fill in each circle with less than, greater than, or equal to make a true statement. So square root of 7. Square root of 7. You have a calculator that will do square root. Square root of 7, and you've got 2 2/3. So square root of 7 as a decimal, 2.64571.311. Here, 2.666 repeating. So if we compare decimals, now when you compare decimals, just a little review from the past. Start at the whole number. If the whole numbers are the same, you move to the tenths. If the tenths are the same, you move to the next digit. So once you get one that's different, you can stop. 4 is obviously smaller than 6, so that means square root of 7 is obviously smaller than 2 2/3. All right, next one, 15.7%. So if I'm going to change this to a decimal, you can make 15.7% a decimal just by moving it back. So 0.157. If you take the square root of 0.02, it comes out as this, 0.141. So let's compare. So 1's same, 5 and 4. 5's obviously bigger, so that means 15.7% is bigger. So that's a greater than. All right, number 6. Put them in order. So in order to put them in order, I would change them all to decimals. So this is already a decimal. It's easy to change 5 4/5 to a decimal by dividing. That would be 5.8. 6, already there, no need to make it a decimal. We've got 5.36 repeating. And the square root of 30. If you work out the square root of 30, you got 5.18. Now, if I ask you to put them in order, I'm not going to ask that you do this graphing on a number line part, so don't even worry about that. Just write them in order is all I need. So if these are the decimals that I'm comparing, obviously 5.37 is the least. Now, I'm not going to write 5.37. I'm going to write that is the equivalent of what number, which is 5.36 repeating. So I would write 5.36 repeating. That takes care of that one. My next one is 5.48, but again, that represents something else. So next I'm going to write square root of 30. Takes care of that one. Last two, I've got this, 5.8, which is 5 4/5. And then I've got 6 at the end. So that is those numbers put in order. And again, I want to stress to you that I'm not putting the decimal equivalents in order. I'm actually putting the numbers that they started with in order. All right, try the next few under got it. Pause it and let's see where you get to. Okay, back with me. Let's talk about the symbols that go in here. So on D, the symbol goes in here is less than. For E, greater than. F, equal to. Now, putting these in order, again, you need to change these to their decimal equivalents. Decimal equivalents. Here's what you would have. You would have negative square root of 60 is the least. Negative square root of 60. After that, you have negative 7 7/10. Okay, next you would have negative 66 over 9. And once I have those three, you should be able to tell me what comes last, which is the last one there, negative 7. All right, so hopefully those all work out for you. If not, make sure that you bring up this example in your notes, because of course you're taking notes on all these examples, right? If not, you should be. So let's go ahead and look at guided practice. So guided practice, number 1. Name all the sets of numbers that these belong to. So when you name all these sets of numbers, that is a repeating decimal, so that is rational, and it would be rational only. The negative square root of 64, that would be negative 8, which is an integer and a rational. That is not a counting number, that is not a whole number. Negative 8 is neither one of those, so it's integer and rational only. 3 is irrational only, that will not come out even. 4, greater than. 5, equal to. 6, greater than. And the last one, number 7, put them in order. In order would be 220%, 2.2 repeating, square root of 5, and 2.25. So again, you have to put these in order by finding their decimal equivalent to begin with. So convert all of these to a decimal with a calculator. That should not be a hard task. Okay? So good luck with those. If you have any questions, let me know.